Okay, so the 11th day. So yeah, this was as annoying as the game might seem. So basically in this problem, if we remove all the story, we have a couple of lists of numbers which represent our item worry level. Then for each of these lists we have an operation that we apply on the list. It's basically a multiplication or an addition or something like that. And then we have a test. We have to test if the value is divisible by a certain amount, and if the test is true, then we have to move the item to another list, and if the test is false, we have to move the item to yet another list. So for the first part, we'll have to simulate all this stuff. Basically for the first monkey, we have to go through all the items and apply the operation and the test. And in the first question, basically to not overflow the numbers, because this can get quite large, especially that we have to because we also have this operation that squares the numbers. We'll get pretty large numbers very quickly. So one way to keep it like not get out of hand, we can divide it by 3. So this is what it tells us in the statement. And the answer what we need to provide is to figure out which were the 2 monkeys that inspected the most items and multiply these numbers together. So in their example, the first monkey inspected 101 items and the fourth monkey inspected 105 items. So the answer was 10,605. Then for the second question, to be honest, I didn't realize it very quickly. It took me a lot of time, but the idea was that we are not allowed to divide by 3 anymore, and we have to figure out another way to keep the worry levels manageable. I guess for some people it was really easy, but yeah, the idea was that you would see in the input that the tests are done with prime numbers, and the idea was that you can multiply all these factors together and you'll get a large number. And what we can do is to apply modulo on all the items after each operation, because yeah, for some reason it won't interfere with the divisible test. So yeah, basically if you have a number and it is divisible with 23, the same number, if you apply modulo 23 on that number, will still be divisible with 23. So yeah, I guess this was a pretty tricky question, at least for me. So for the answer we have to provide the same thing, but this time we are interested in the monkey business level after 10,000 rounds, not 20. So for the solution, I created an enum for the operation. This is the operation that the monkey does on the item value, which can be a multiplication, an addition, or a square operation. Then I implemented from string trait for this operation. I mean, I guess it's pretty obvious. You just have to split around the string on equal signs and rename it to make sure that you don't have white spaces, and you have to figure out if you have a star in the string. If you have a star, then it means that you have a multiplication or a square operation, and the easier case is when you have a plus. When you have a plus, you just take the right hand side, which is the value, and you return an add operation. But if you have a multiplication, what you can do is to check if the right hand side is a number, and if it's a number, then it's a multiplication, and if not, it's a square. I also have this function called apply for an operation, which just does what the operation says. So if it's a multiplication, it multiplies the value with v. If it's an addition, it adds v to the value, and if it's a square, it squares the value. Then for the test part, I created a struct, and since all the test operations are divisible by, I just have a divisor field with a type usize for that value, then a true index and a false index, because again the only things that the monkey does is to throw the item to another monkey. So to read this thing, I sent to the from string trait the last 3 lines. So the function will split by lines, then it will take the first line and search for the number. So it will basically split by space and take the last item, then convert it to usize. And for the true index and false index, we have to do the same thing basically, because again it's the last item after the space, which is the index. Then I created a test function which takes in a value and returns the index where you want to move the item. So this function checks if the value is divisible by the divisor, and if it's true then it returns the true index, and otherwise it returns the false index. Then I also have this structure called monkey, which will contain a queue of items. I guess deck is just that, like a queue. The operation that the monkey does and the test that the monkey does. To make things easier, I added an inspections field which keeps track of the number of inspections. And to read the monkey from a string, I just applied all the parse functions that I implemented so far. Then I wanted to implement ord for a monkey to make it easier to sort all the monkeys after we apply all the rounds and get the maximum monkey based on the number of inspections. So ORD will just compare the monkeys based on the inspections field, which is a new size, so we can use CMP and partial CMP and also equal. Then I created two functions, act for part 1, which applies the operation on the item and divides it by 3. Then it gets the next index and will return a tuple that says what item to move to which monkey. For the second part, instead of dividing by 3 the item after we apply the operation, we modulo it with the common divisor, and again we'll return the item and the next monkey. Then the round function will go through all the items of a monkey and it will get all the actions that it did. So basically it will get a list of tuples of items and where to move the item. I also have this give function where you specify an item and it just adds it to the of that monkey. To parse the input, I split it by double new line and then parsed each string as a monkey, so we get a vec of monkey. For the first part we have to do just 20 rounds, and what I did was to iterate through all the monkeys, apply the round 1 function, get the list of actions, and then give the item to each monkey that needs to receive it. Finally I sorted the monkeys in descending order and multiplied the number of inspections of the top 2 monkeys. For the second part we do the same thing but for 10,000 rounds, and we also have to provide the round function with a common divisor, which is just the multiplication of the test divisors. And at the end again we just sort the monkeys and return the multiplication of the top 2 inspections. So yeah, this was the 11th day. It was pretty cool, but yeah, it somehow tricked me, but I still think that the idea was interesting. So yeah, if you want to look at the code but pretty bad, you can find it on my GitHub. And yeah, see you guys next time.